Here we are at example 1 from the 1.2 set of notes. Now, if you recall back in geometry, we studied these things called secants. And a lot of times, we study these things called secants on a specific circle. Now, a secant, again, is maybe where you just have some circle and like a point A here, and we'll just say there's some point B here. And the secant is pretty much just that connector that connects A and B. And with that, a lot of times what we found out was the distance between A and B. And a lot of times, too, with that, we kind of, like as an aid that helped us out, we put this on like an XY plane, and then we could actually find what that distance was using, hopefully it's coming to mind, the distance formula. Now, if you may or may not recall, the distance formula just comes out to be the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Now, the beautiful thing is these distances, when we're talking about actual functions, like on an xy plane, behave actually the same identical way. So we notice if we're trying to find out what is this point and this point, what is that distance or that secant, all we're going to go ahead and do is plug these values into our distance formula. So I'm just going to go ahead and label this one x1, y1. And we're going to say that this one is x2, y2. So now going ahead and plugging in our values, we have that distance is equal to the square root of x2, which is 3, minus our x1 is 0 here, quantity squared, plus our y2 was 4, minus our y1 is 1, quantity squared. And so this should simplify out to be 3 minus 0 is 3, quantity squared is 9, plus this will just come out to be 3 squared, which is again 9. And so we end up then with the square root of 18. Now, just doing a little bit of good and garbage, that comes out to be 3 root 2. The reason why that works is we can do good with 9 and garbage of 2. And so you end up with this. Now, what happens though if, for example, we said we're going to include 2 secant lines? Well, the game is still exactly the same. You're still going to go ahead and use the distance formula. However, for this one, we end up with, we'll call this guy still x1, y1. We'll say that this point right here, which appears to be about 1.5, and we'll say that the y value is maybe 0.25. Looks pretty close to that. So 0.25. And again, that is our, we'll call this one x2, y2. And then this 0.34, that's our third point, we have as x3, y3. So what you're going to end up actually doing is you're going to find the distance between these 2 points and the distance between these 2 points, finding each distance secant, or each secant's distance, I should say. Now, let's go ahead then and even just show what that would look like so you guys have that for your notes. So we have the distance is equal to the square root of 1.5, just doing this first one, 1.5 minus 0, quantity squared, plus 0.25 minus 1, quantity squared. And then you would have to tack on then this distance as well. Because you're finding in this first calculation this secant, but then you also have to tack on whatever this distance is. So then we end up with the square root of, looks like it's 3, yep, 3 minus 1.5, quantity squared, plus 4 minus 0.25, quantity squared. So that would just be the setup of things, and this should come out to be about 5.71592. Well, what happens now when you do 4 points? Ooh, that would be a lot of calculations if you actually had to do by hand. I'm going to go ahead and kind of skip things though. When you actually do, I think it's these two, you end up with 2 root 2 in the end. So for this distance, you should end up with root 2. This one also comes out to be root 2. And this distance right here comes out to be root 10. So you would actually end up with 2 root 2 because there are 2 secants that have that same distance plus the square root of 10, giving you then a grand total of 5.99, roughly 070. All right. So now, again, just kind of looking at things, here we're just finding the secant between 2 points. Here we had 3 points to work with. And then here we had 4. So hopefully you're starting to kind of think, well, as we increase the number of segments, what are we finding then? Well, the thing that we're finding as we increase the number of segments, or increasing the number of secant segments, also known as increasing the number of points, they're all kind of meaning the same thing. What we actually end up finding is the actual length of our curve. Because even in just looking at our curves, here was 1. Well, okay, that's an okay approximation. As you increase and say, well, I'm going to now have 3 points to work with, you can kind of see maybe, hopefully at least, a better approximation. Then as you do 4, you can kind of even see a little bit of a better approximation with finding that total distance of that curve. Now, finally, how many segments would you have to have for the absolute best approximation? Like, how many would you need? You would actually need an infinite amount of them. And as you increase the number of secants, or number of points, the idea then is that you start having the best approximation for your curve. So for this one, as you guys can see, I'm just increasing a lot of little different points, creating those secants, and then you would find a heck of a lot of distances to find out an approximation of that distance of the curve. All right. So again, that is example 1 from the 1.2 set of notes.